All right, I think Eileen is joining us now, and I believe, Greg, are you on already?
Yep, Jason. Yeah, I apologize everybody for a slight delay in the start. We were just finishing up our overall briefings that were on the main YouTube channel, so I appreciate everyone sticking around, but I really look forward to this incredibly fruitful brainstorming session. So I think, Eileen, you wanted to talk for a couple minutes with just a couple introductory slides.
Yep. Eileen, you're on mute.
What about now? Can you hear me?
Yep, we can hear you. Thanks.
Okay. Do you want to share or do you want me to do it?
Let me make you co-host. And Greg, I'll also make you co-host as well once I find your name.
Needs to put my MIT hat on. I like it, Mark. I usually put on my brass rat for these things, but I didn't today. I see Greg. Hi, Greg. Haven't seen you for a long time.
Hi there. How are you?
Good. I actually meant Greg Eric, but hello, Greg. Eric. Hello, Eric. Nice to see you too.
Greg, yeah.
Hi, Eileen.
All right, Eileen. You can please share your slide.
Okay, let's try doing this. Share screen. Here we go. Okay, go to this. I'm just gonna jump. Oh, never mind. Try that one more time. Share screen.
All right, for those of us who are just joining us, you are with Eileen and Greg. They will be sharing giving you a brief introduction on microelectronics, and then we'll jump right into the workshop.
We see it.
Great. What do you see? U.S. investment in microelectronics startup?
Perfecto.
Okay. So really, we're just going to show two slides from the ones that we had here. I think kind of the first challenge we have, and many of you I know this, is that, but here's some numbers just to prove what many of us know. From an innovation point of view, we really see a very much a weakened number of investments going into the semiconductor space. So last year in 2019, only 0.5% of all U.S. venture capital deals were in semiconductors. If we were to look globally, the U.S. is about half in terms of the number of deals that were invested in. And I'd say, just as a venture capitalist in this area, what you see is the AI, anything with AI in it gets funded. If you're a sense, compute, memory, et cetera, you might be able to get seed and early stage. But the late stage investment is very difficult. This is something I feel like DoD can help with, and something we should discuss the solutions here. And then just some numbers under there. You see that China deals on average are getting about 30 million, whereas US deals are getting about 11.4. So that's just on the kind of innovation side. And then I'll hand over to Greg to talk about effectively kind of the importance of this from a DoD point of view. It's this one, right, Greg? Or is it the...
Yeah, Eileen, yeah, if you could make that a whole screen, like the
Sure thing.
First one, I'll run through the first one real quick if you go back
Okay.
to the slide. Okay, so this is what many of you know, but as we communicate within this community, the need for microelectronics and national security applications, on the DoD side, it's kind of the KISS concept, right? Keep it simple, stupid. So as we shift to great power competition, technology means military dependence, right? And it's the guts that count. It's everything inside the weapon platform that is going to significantly drive those capabilities above and beyond what a technologically advanced adversary can bring to bear. So I bring in the F-35 with its 24 million lines of code. If you're from the F-35 program, I'm sure it's more than that at this point in time, but this was a couple of years ago. most of our weapon systems have 10 to 20 plus year old technology. And while that may be appropriate for certain applications, for a broad swath of application, it is not. And I list hypersonics, 5G, AI, missile defense, autonomous systems, space. There's a lot of other applications. And when you talk to your DoD customers, if you can boil it down to this one thing, everybody on our side knows the OODA loop. We get ingrained in this from the very beginning of our professional military education. It's the observe, orient, decide, act, the OODA loop. And the way that microelectronics helps that is we take in all this sensor data, so we observe, right? And we orient in terms of processing that data, and then we display it in a way that somebody can make a decision and then act on that decision. And so that's really speeding up that OODA loop faster than what the adversary can. This is going to be key, as you guys know, to every single, I shouldn't say every, I always hate as a technical person saying every or all or none, but for almost all new military systems, advanced microelectronics is going to be key to those capabilities. Sensor data fusion, fast decision making, and on top of it, we're not the only game in the town. Right now, as you see in that chart, there were 13 companies at state-of-the-art in 2007, around 45 nanometers. That is now down to only 3 in the world. And potentially a fourth coming up, SMIC or SMIC from China. And so you better believe that our adversaries or competitors, or however you wanna describe them, are going to absolutely have these capabilities, and we need to as well. So if you can go to the next slide, I'll just go over the overall challenges. Okay, so as we talk over the next hour in our brainstorming session, these are the overall challenges to getting state-of-the-art capabilities into our system. And I lump them into 2 different areas. And it's kind of somewhat, that's qualitative, right? And you can lump them into different categories if you want.
Greg, somehow you went on mute. Not sure how that happened.
Yep, that was my part of me. That.
Okay.
Yeah, go, sorry.
Okay, so I lump it into 2 general categories: system requirements and supply chain. So under system requirements, we have extremely unique requirements, whether that be in unique sensor fusion applications, unique AI, advanced packaging that can lead from those other operational requirements. We have unique environments like radiation hard, temperature, vibration, shock, high reliability, where we absolutely need to know that things work when we intend them to work. And there are some corollaries to that in the commercial space for, say, autonomous automobiles or aircraft systems. But in terms of, say, nuclear certification, that gets brought to a whole nother level. Long lifetimes. A lot of our systems are out there for multi-decades.
But you don't want to listen to the microelectronics discussion if I leave.
Really?
Huh?
Please go on.
What?
So I'll keep, sorry, I think somebody has a hot mic there. So multi-decadal, now we can change that as we develop our systems. There are reasons why sometimes systems cannot be upgraded for multi-decades. Security obviously is important, not just at the fab, but all the way from the very beginning in the design tools, all the way to the product getting out the door to say a prime contractor to incorporate. Long system development and production timelines that can take into account technology freezes. ITAR and EAR is absolutely an important discussion right now that we're engaged in. I will tell you right now, it is limiting our ability in some programs to get the capabilities we need to get in front of emerging threats in the future. Low quantities, you guys know, in the market, DoD is a lot less than other commercial needs, like iPhones, for example. There's high input costs. Shuttle runs are in the millions. Design tools, millions per year. One fab tool is hundreds of millions. I didn't put exact numbers, even though we have them, but I wanted to keep that proprietary information out of this presentation. Overseas production that Eileen has talked about, and limited manufacturers, only 3. Now, this is just one example. There are a lot of spaces in the microelectronics area where this is the case, but in one example, at the most advanced technology nodes, there are only 3 companies in the world. One of those is only one of those is U.S. owned, and another one could soon be SMIC or SMIC, and will definitely enable the Chinese to have those advanced capabilities, and I'll just leave it at that. So as we look at this brainstorming over the next hour, I'd like to keep these challenges in mind. So what's going to happen next is that we're going to have a digital whiteboard. We're going to have our AFWERX moderators go through some of those questions that are similar to all potential Air Force Prime initiatives. And I invite all of the discussion and people to speak up.
We are moving into microelectronics. We're focusing on innovation, and particularly innovation for packaging. So, Eileen, do you want to kick this off, or would you like Greg?
I can start. So I think I'm not going to pull up the slides again. I think if you look at kind of the attack surfaces in the semiconductor process, which is related to the supply chain, you know, there's pre-silicon, and we talked about that in my talk. There's, of course, when things are actually being made, so attacking the foundries themselves, the tools themselves. And then, of course, there is post-manufacturing, when you're actually putting things together and packaging. And our belief, you know, at In-Q-Tel, my own belief is that the DoD, you know, as much as they can and not in all situations, should really just move to more COTS. So then they leverage the cost curves of the industry, and then effectively have the innovation in how things are put together on the packaging side of things. So that's sort of just a strategy to ensure that the DoD gets the latest parts from a kind of national leadership point of view. I think, you know, I was talking to some of my ex-colleagues that applied. I mean, I think you all know that our passports changed over the 20-some years. You know, first we were all going to Texas and Arizona, and then we were all going to Japan, and then we were all going to Korea, and now we're all in the industry, and now we go to China. Sorry, and Taiwan, of course, is in there too. And so we have pretty much let TSMC take this entire industry from us on the manufacturing side. On the packaging side, you know, they're not standing still. They have lots of PhDs and et cetera, that they are going to try to own this. And this is an area where I think the US, really leveraging some of the other sectors that we're really great at, can take back and be a leader here, but there needs to be a focus. Again, if people were to look at the Chips for America bill and some of the bills that are on the Hill, you will see that there is focus on packaging. Packaging is a broad term. It means everything from IT to IP to materials to the equipment. And I do feel that it is an area which has broad applicability, broad strokes here. And then the last point I was going to make is, you know, we're very behind on the semiconductor funding of startups in the space compared to China. I think you guys have seen the slides. It's pretty much a disgrace in my opinion. So I think, again, we need to mobilize and do something here. And I feel like AFWERX And this being a prime can be a real jump start to getting these companies the money they need and effectively the demand that they need.